Okay, what's wrong with this? Come on, I hate that. What's wrong with this today? Okay, so did you guys take a look at number one? In number one, all you have to do is graph the function. For each function, you're going to find domain, range, and where the function is increasing and decreasing. So which one you think you need help with? Is there any question particularly you need help with here? No? Say graph. Sketch of the graph. The square root? Sure. Thank you. So square root of function, if you have no idea what's the shape, you can Google it. The shape of the square root function starts from 0 and it goes upward slowly. So this is x, this is y, and this is the function of graph of the square root function, square root of x. Now this is an interesting function. It doesn't have anything before 0. So domain means all the x values you see in your function. So based on the graph, where your x value starts or where the domain starts? 0. And when you have a 0, we do have a valid y value here. So it's a closed bracket. Closed bracket means we don't have any hole in our graph or in our function. We have a y value for that x value. And now you see all the x values we are applying here, and we don't have any problem with any of the numbers. So what's the largest x value we can apply in our function? Infinity. If it is a symbol, so we use parentheses before that instead of bracket. So domain means look at the x-axis and see which x values you're applying in the function. Range means which y values you see in the function. So in your graph, what is the smallest y value you see? 0. Just like domain, the smallest y value is 0. It doesn't have any hole, so it's a bracket. And the graph is going on forever on upward. It grows slowly, but actually it goes on forever. So what would be the highest y value you can see in our functions? So surprisingly, as domain and range, the same thing. Now comes increasing and decreasing. Increasing means on which x, from which x value to which x value the graph is going upward. So we start our function from 0. So that's the smallest point we have. And then when you walk from the left side to the right side of the function, so I'm starting my walk from the left side here, and I'm going toward my right side. Which direction we went? Upward or downward? Upward, right? We are going up forever. We are going slowly, but we are going up forever. So our increasing interval starts from 0 and it goes on forever. Oh, we don't actually have to put bracket here. We can simply put parentheses. For increasing, decreasing, the bracket or parentheses doesn't matter. Okay, you can put bracket. It's not a problem, but we don't care. But in domain and range, we must care about whether it is bracket or parentheses. For increasing, decreasing, we don't care. If you want, you can put bracket. If you want, you can put parentheses. Okay, so in this function, are we decreasing anywhere? So for decreasing, what do we write? DNA or none. We don't have any interval where we are decreasing. Any question on the explanation of this question? Nobody has any problem? Okay. You can try the rest 5 of them by yourself. Do you want to try them now, or you want me to do next question? What do you think? Which one? Piecewise function? Great. Students actually have problem with piecewise function. Not only you, most of the students. And that's because piecewise meant to be hard but confusing. Okay. Good news is that I will explain it very easily. So whenever you don't understand anything, just ask me a question. Piecewise function. It means you have different pieces of functions together in one plane. Okay. So in this function, we have 3 pieces. Our first piece is y equals 4 when we have all the x values smaller than -2. These are first piece. Piece number 1. For all the x value that is smaller than -2, we do not include -2. For all those numbers, our function is y equals 4. Y equals 4, which type of function is this? Or what's the shape of the graph of this function? It's a line, a horizontal line, right? So when y is 4, 1, 2, 3, 4, we have a line here. And it says it's a line for all the x values till when x is -2. So x -1 here, x -2 here, y equals 4 here. Our first function is y equals 4 for every number smaller than -2. But when you have -2, there is no y value for that. Why not? Because they did not give us any equal sign. No equal sign means no y value, i.e., it's a hole in the graph. Okay? So for everything smaller than -2, our function is y equals 4. But when x is exactly -2, there is no y value. Why not? Because in our domain, they did not give us the equal sign for x smaller than -2. They only says for everything smaller than -2, that's the function. Any questions so far? Okay, now let's go to the next portion. Next portion of the graph is y equals x squared for everything between -2 to +2. So let me do it here. Y equals is of portion 2, y equals x squared when we have all the x -2 to +2. Observe they gave us an equal sign here. So when x is -2, we do have a y value. But they did not give us any equal sign for 2. So when x is 2, no y value. I mean, we're supposed to have a y value, but we don't get it, instead we put a hole. Okay? And since, what's the shape of this x squared function? Parabola. So we have a parabola from -2 to +2, but we want to draw it more precisely. So let's see what y value we have for every x value between -2 and +2. So when x is -2, we get y value -2 square, right? What is -2 square? 4. And then let's say when x is 0. What's the y value we have? 0. And we're not supposed to have x value 2, but suppose if we had x value 2, what would have been our y value? Positive 4, right? It should be positive 4, but since we don't have the x value there, so our y value have a hole. Okay, so when x is 0, y is 0, when x is 2, y is 4, and when x is 2, y should be 4, but we don't have anything, so it's a hole. When x is negative 2, we have a positive 4, then we have a parabola here. When x is 0, we have a 0. When x is 2, we're supposed to have a 4. Let me write hole here so you'll understand. But we don't have any y value. We simply have a hole there. Okay. Right. So if your domain if x doesn't have the equal sign, that is the y value is supposed to have there, we'll have a hole. So where did the limit stop to go? Right. Now observe something interesting. The left graph says point x is negative 2. We don't have any y value. But the second portion of the graph says when x is negative 2, we do have a y value negative 4. We do have a y value positive 4. Now, do we have a hole here or do we have a closed circle here? Both. Right, you have both. So which one has the priority? The hole or the closed circle? Which one you see there right now?
The closed one because it connects both points.
Exactly. The closed one fills the hole. That means we don't have any problem when x is negative 2. Right? The graph is still continuous from infinity to x value 2. We have all the y values exist in our function. Individually, they did not have any y value in the first portion, but since we combine the second portion of the graph, now we have no problem. Right? Do you see that? Okay, now comes our third portion. Let's pick blue. Third portion of the graph is the last one. Y equals negative x for x is bigger than or equal to. Y equals negative x. What's the shape of the function? It's a line that is going down. It's a decreasing function. Now let's be more precise. We start with positive 2. We are allowed to use it because we have an equal sign. So we are going to have a valid y value. If x is 2, what is our y value for this function? Negative 2, because our y is negative of the x. Okay, so we found one function. So one point. When x is 2, y is negative 2 here. And it's a closed one. Now let's pick another one. When x is 4, what is our y? Negative 4. So when x is 4, our y is negative 4 here. So the graph is going this way. So 3 colors for 3 different functions. All pieces we put them together on the same Excel plane. Is it clear how to draw piecewise function? Who is still confused? Guess what? In the exam, you're gonna draw one piecewise function. So if like two parts of the domain, the second one have a function that will have a triangle, circle, and then if two of the functions except for a circle. As long as one of them has equal sign for the domains. But if none of them have equal sign, that means it's a hole. So whole or not whole, it depends on your domain. Domain, if you have equal sign, let me erase my red one so you can see. See, this graph has an equal sign here. Since it has an equal sign here, so x equals negative 2 as a valid y value, so we get a closed circle for point x is negative 2. But point x is positive 2. These two functions, they don't standing one on top of another one. They have two different starting and ending points. This one has an ending point on the 4. This one has a starting point at negative 2. So they don't stand on top of one another. But they do. That means if you observe, the graph is continuous from negative infinity until the x equal 2. And then at 2 it's not continuous. It jumps. And then it's continuous forever. Okay, so we have only one problem. At 2, because at 2 we jumped. So when x is 2, do we have a valid y value? We do. Even though it's on have here, but look, we have the y value here. That means we use every number on the x-axis in our function. And we still have y value, valid y value for every number we used. Do you see that? If you don't ask me, please, because you're going to draw this in your exam. So if you're confused, I'm here to help you. You're okay? So what's the domain then? Great. That's why I was keep asking you, do you have any y value? Do you have any x value that doesn't have any valid y value? We don't. Every x value we have, it has valid y value. This x value, x2, has a valid y value. This x value 2, we don't have anything there. Well, who cares? Because we still have it down part, on the downside. So 2 has a valid y value, negative 2 is a valid y value. That means we did not have any break in our domain. So with everything on the number line from negative infinity to positive. But the range is actually not same. Range means observe your y-axis. The function, what do you see in the function? How the function is moving in terms of y-axis. Negative infinity. And it's true, the highest point is 4. The lowest point is negative infinity, the highest point is 4. But did you use everything from negative infinity to 4? What do you have for y equals 1? Y equals 1 is here. Do you have anything for y equals 1? Is there any graph here? How about negative 1.5? Do you have any graph here? How about negative 0.5? Okay. We did not use every y value. We used all the y values from negative infinity until negative 2. And there is nothing between negative 2 to 0, right? There is no graph here. That means we have a break in our range. And we have to introduce every break. So it starts from negative infinity until it reaches negative 2. And negative 2 has a closed circle, so it's a bracket. Union, and then suddenly we jumped from negative 2 to 0. So next journey starts from 0, and then we have all the numbers up to 4. So starts from 0 until 4. We have a valid y value for 4, and we have a valid x value for 0. So we have a bracket for both of them. Is anybody confused? No. Or you simply care? Which one? You're okay? You don't care? Or you're lost? One of the three. Pick one of them. Which one? Are you okay? You lost or you don't care? Okay? Question.
So if both of the circles were open with brackets,
It will parenthesis. Huh? Now they're asking one more thing. Intercept. So what's the intercept you see here? What is our x-intercept here? What is our y-intercept here? So one more part. X and y-intercept, they both are at 0, 0. The next page is all about quadratic parabola. Do you know how to convert standard form, no, general, no, whatever. Do you know how to convert into vertex form of the parabola? That one is given, I believe it's called general form. I get confused about general or standard. I think this is standard, no, this is general form. So convert general form into standard form. Standard form has another name, vertex, because you can see the vertex there. So you guys okay with converting general form to vertex form? Go over? Okay, no problem. So this is general, if I'm not wrong. I could be wrong, but as far as I remember, this is general. And our goal is to convert this into vertex form, or they have another name, standard form. The standard form is y equals some type of leading coefficient a, x minus h square plus k. It's called vertex form because we can see the vertex here. Combining h and k, they give us the vertex. That's why we like vertex form, because you can see the vertex. Why do you care about the vertex? Because vertex gives us either the minimum of something or maximum of something. And we love to work with minimum or maximum. For example, when we buy things, we want to spend minimum amount of money, right? So you see, minimum. And if you are a businessman, or if you own a store, you want to get maximum profit, right? It's a reality. So you see, you're talking about maximum. So minimum and maximum, they are very important part of our life. That's why we want to work with vertex form, because the vertex gives us when we have a maximum and when we have a minimum. On the other hand, the general form is kind of useless for everything else except for one place, to find the y-intercept. To find the y-intercept is the easiest one because it cancels all the x's. Whatever remains, that is our y-intercept. Y equals the constant. So general form has only one usage, one usefulness for y-intercept. Except for that, for everything else, we prefer vertex form. And x-intercept, it depends. Sometimes it's easier to find x-intercept for the general form, but it's always easier to find x-intercept from the vertex. Okay? So our goal is to convert that thingy into that piece. So we have y equals negative 3x squared plus 6x plus 1. So what you're going to do is we are going to complete a square. Using complete the square method, we can convert this into that portion. But in order to complete the square, we cannot have any leading coefficient. That means this negative 3 is a problem. We must pull it out, otherwise we cannot complete the square. So I pull out -3 only from these two. Okay, we are going to leave one alone. We are going to pull out -3 only from all the x terms. So if you pull -1 out, so -3 out, what is left in the first term? You have -3x squared, you pulled out the -3, what remains? X squared, and from 6x, you left with 2x. And then we put our +1 aside. Okay. Now you're going to something interesting. We want to add something extra here. Let me pick green. Add something extra here so that this thingy will become same thing twice when you factor them. What number you can add there so that when you factor, you get the same factor twice? 1. Perfect. The rule says all you have to do is whatever you have, divide that by 2. So you get -1, right? So we add, oh no, let me this. So we add this -1 with a square, and we subtract the same amount with a square. Because in math, remember I said math, oh sorry, I didn't tell you. I said in my bio stress, math is fair, okay? It cannot just randomly throw something to anything. So we needed the -1 square because we need to factor things. But then I says, well, you cannot just give me -1 square. If you give me -1 square to subtract the same amount so that it don't change my original structure. So if you add the -1 square, you must subtract that. Otherwise, it's wrong. So that's why the first one we did because we need it, but second one we did because math is fair. And then we have the extra one outside. Now, if you observe the first 3 terms, well, never mind. Let me rewrite first. It will be easier. So we have -3 x squared plus 2x plus 1 minus 1 plus 3. Right? Now, if you observe the first 3 terms, our goal is to factor this. So when you factor this, what do you get? 2 numbers multiplied to 1 combined to 2. What are the 2 factors? X plus 1, x plus 1. But why wasting our energy writing it twice? So what we do, we write it only once. We have y equals -3 x plus 1 square. From these 3, sorry, these 4. Two x is negative because we pulled out negative. Yep, thank you. So this is negative, this is negative, this is negative. So these two convert into this, which convert into a perfect square. So we completed our perfect square, but we are not done. Because here comes all the extra thing we did not use. We did not use this -1, right? So we need to pull it out from inside the bracket to outside the bracket. If you pull it out from inside to outside, we get a -3 here, right? -3 times -1 gives us +3. And we have this 3. So So what I did, from the x terms, we pulled out -3, and then we left our constant alone. Now from here, we needed one extra number so that we can factor it twice. So what we need is half of the middle term. So whatever we need to add is the half of middle term squared. So -1 squared, we added because we did, but then we have to subtract because this is what makes us. We add something, subtract the same thing at the same time. So we get x squared minus 2 is +1, and we get -1 here. Now we need these three to factor, but we did not use -1, it was extra. So the extra thing, we have a -3 on the front. So when we take out this -1 from inside the parentheses, it doesn't become -3, it becomes -3 times -1, which turns into +2. Do you see that? Is there anybody who does not see why -1 turns into +3? Come on, guys, don't be like statues. You're a human being. Talk. Response.
So like that can be the outside term and that will become 8.
True. 8, not 8, right? 6 or 8. So whatever is the leading coefficient, that is our 8. See that 8, we need a leading coefficient. That number is our leading coefficient. We pull it out, so it is -3. We complete the square, so we have x minus 1. My bad. Minus. We have x minus 1. And then we have extra 3 from inside -1. And we have, why do you have 3 on the outside? Typo. No. Sorry, my bad. It's a 1 from here. It's a 1 from here. See, I also make mistake. I'm also a human being. Just like you guys. So talk. Okay, when I ask you a question, response. Catch my mistake. Like they hit it.
It's where I thought you subtracted from the the b value and then also the c value. So I thought it would be 2x +1 and 5 outside.
We cannot do -1 outside because it pulls out. If it did not pull out a 3, -3, then you could do that.
Oh, okay.
So when you,
like if it's already like 1.
when you take out something as a common factor, this number is not alone anymore. It has a problem with the outside number.
Okay.
If we did not have to take anything out, then you simply add something, subtract something. That's it. But since we had to pull out something as a common factor first, that means we cannot subtract our amount outside of the number. We have to do it inside the parentheses, not outside the parentheses. And that's how the -1 turns into a +3 because we had to multiply from -2. So we have a +3 and then extra 1 outside. So combining all of them, now we have y equals -3 x minus 1 squared plus 4. What they want us to find? Vertex, x and y intercepts. So we already found y intercept, right? These are y intercepts. We already done with one of them. Now we can find the vertex. What's the vertex here? Remember, vertex is h from the inside, k from the outside. So what is the vertex? 1, 4. So we found vertex. We found vertex, we found y-intercept. Now we need x-intercept. Question?
Yeah, I thought it was -1 on 4. Oh, never mind.
The rule says H is negative inside the parentheses, but when you pull the number out, it changes sign. So if you actually had a positive number inside the parentheses, it would have been -1. For example, if it had y equals, let's say, 5x plus 5, 5x plus 3 square minus 2. Suppose you had this, then your vertex would be what? Opposite sign from the inside, which is -3, but the same thing from the outside. So vertex always is the opposite sign from the inside, but the same sign from the outside. So H changes sign, but K doesn't change sign. In our case, we have H1 and K4. Are you guys lost? No. Okay, then you can find the x-intercept by yourself. From the last 3 questions, set the y0. So x-intercept means set y0, and we solve for x. So we have 0 equals -3, x minus 1 squared plus 4. Use reverse PEMDAS to get rid of everything one by one from x. Whatever you get, that's your x-intercept. And since it's a parabola, you're going to get true x-intercept. And then you can sketch a graph. Okay. Do you guys need any help for next 3 questions, 4, 5, 6? Do you think any of them are hard? Any question from anyone? No? 6? Sketch a possible graph of quadratic function whose discriminant is 0. Good question. Discriminant is 0. What is discriminant? Good. So when you solve for x-intercept, we have -b plus minus square root of b squared minus 4ac whole thing divided by 2a. They are saying that this portion, they are saying that this portion, this discriminant, is 0. It means you have your x-intercept -b over 2a. So how many x-intercept do you have? Only one, right? Only one x-intercept. And it says the graph opens upward. Upward means U or upside down U. Which one? U. So how can you draw a graph that is upward, but it has only one x-intercept? How it's possible? It could be here. This is one example. This is only one x-intercept. Or if you want, you can draw a parabola on the right side. If vertex is on the x-intercept. Or if you want, you can do on the left side of the x-intercept. So left side of the y-axis. So this or this or this. The main idea is you can get x-intercept on one by having the vertex on the x-axis. Only this way you can have one x-intercept. Otherwise, no. We have either no x-intercept or 3 x-intercept. And guess what? You have at least 2 of these in your exam. From these 2. Do you know when is your exam? 30? Next week. Next Monday. Good luck with that. Oh, I wanted to have a review, but I forgot. Okay, I'll do what? If I find my previous semester review video, then I'll just email that to you. And my reviews are actually very good. Okay, if you study all the questions in the review sheet, you'll definitely see them in the exam. You did?
Right.
Yeah. Next week. Oh man, this week at class is after my after recitation. Okay. But if I give you a review just before the exam, you might get confused, right? Huh? Probably tonight. I'm gonna email you tonight. So good luck with your exam, guys. And if you're done with the sheet, you can turn it today. If you're not, give me next class. Huh?